Hello my dear students, I welcome you to NEET World. So this is Ajay Pulla and you are watching NEET World. So in this session, I am going to announce you one very important announcement. See here, we are launching 100 days challenge. Okay, so in this challenge, so what we are going to give you. See, so for upcoming NEET 2026, NEET, JEE and EAP set entrance exams are there now. So for that, so we are we are choosing some top 100 topics, or we are discussing the topics which are very important from each of the chapter that will be very useful for all this NEET, EAP set and JEE 2026, and we are covering them in these live sessions. Okay, so every day we will be having live session at this time for chemistry, and after that we will be having physics and also botany, zoology for NEET students, and for MPC students mathematics. Okay, so this is what we are going to do for the next 100 days. Okay, so you can access all these videos from the YouTube live sessions. Okay, so what I suggest you is just click on the subscribe button so that it will notify you whenever we are starting the class. Whenever we plan a class, that will be comes you as a notification, so you can watch it at the live itself. Okay, so I suggest you to participate in these live sessions every day. Okay, so that you can write in the comment box, and we are here to guide you, and we are here to clear your all queries regarding this preparation. Okay, so let us start our session with very basic thing, that is some basic concepts of chemistry, that is from the mole concept. Okay, so in this from last few days, I mean from last 10 days if we consider, we have did for live sessions on bridge course. So in those bridge course classes, we have given complete basics regarding organic, inorganic, physical from my side, and similarly for physics and bio as well as the mathematics also. Okay, so this is what we did. Okay, so if you are really struggling with your basics, okay, if you are really looking for the best mentor to give you the basics of chemistry, yes, you can go through the playlist of this channel where you can have all the basics. I mean bridge course, it means if you are moving from 10th to 11th, or you are already 11th 12th or dropper student, and but you wanted to know a little basics about this physics, chemistry and mathematics or bio, so you can go through our channel. There you will definitely get all these basic content or sessions which are very useful to build a strong subject of this 11th and 12th for JEE, NEET and EAP set. Okay, so let's start our topic. So what we are going to discuss here, so mole concept. Okay, so after discussing about mole concept, how will we, I mean mole concept discussion means it also includes calculation of this number of moles. Okay, so what exactly mole, okay, and how can we describe in different manner, and how can we calculate this, methods of calculation of moles also we will be discussing. After that we will be doing some numericals, and then we will be moving to discuss about this percentage composition, I will tell you, and the next empirical and molecular formula, then we will do some previous year questions. So this is what we are going to do now. Okay, so let us start. So here, so what exactly a mole? So mole is something like, see here, a mole is defined as amount of substance. Yes, so in order to express how much amount of substance we have, so we are using something like grams, right? Amount in order to express amount of substance we are giving with respect to its mass, right? Okay, so generally we will use that in our daily life. Okay, and even chemistry also will use, but in chemistry we will be discussing, or we will dealing with very minute particles that can't even be seen with our eyes also, right? So in that case, even if we take a little quantity of a substance, it contains so many number of particles, so many number of that particular atoms, right? So in order to deal with those kind of atoms or those kind of particles or micro level particles, we will use this mole as a term to describe them properly. Okay, so what exactly it says is, see, if I say 1 mole of any substance, so if I say 1 mole of any substance, so it has this many number of the atoms or the particles, 6.022 into 10 power 23 particles will be there. Okay, so 1 mole of any substance, 1 mole of any substance, if someone gives you, okay, and ask how many particles will be there, for example 1 mole of some sugar is given to you, now tell me how many sugar particles, I mean sugar molecules, like what is the formula of sugar? Sucrose, no? So how many sucrose units will be present in that if they ask you? So how can you say, so this many glucose sugar like units will be there, sucrose units will be there, you should answer them. For example, if someone asks you 1 mole of pens I am giving you, so now tell me how many pens in number. So how many pens in number? This many number of pens that person have given you, like that you need to understand. Okay, it's a hypothetical case to understand the concept I am giving you. Okay, now for example, if we go to the market, we will be saying dozen apples, right? So what do we mean by dozen apples? 12 apples we are saying, na? Similarly, if we say dozen, instead of using dozen, if I say 1 mole of apples, so you should understand that this many number of apples you have taken. It is a very big number, see, right? So it's a very big number, 6.022 into 10 power 23. It means after this 2 we have 23 zeros are there. It means remove this decimal and you can multiply with this, so you will get around some 20 zeros after this number. It means very big number, no? Yeah, so that many particles will be there in the 1 mole of any substance. Okay, so now here you can read, see, this number is called Avogadro number, indicated with symbol Na. So what is this Avogadro number? So 6.022 into 10 power 23 is considered to be Avogadro number. Okay, let us understand little more. A mole is defined as amount of substance that contains as many entities or particles. It may be atoms, molecules, ions, electrons, protons, neutrons, or anything, as there are exactly in the 12 grams of carbon. Okay, carbon C12 isotope. So now it was found that practically 12 grams of C12 carbon has been taken, and it has found that, so in these carbons, 12 grams of this particular carbon atom containing Avogadro number of atoms, Avogadro number of these carbon atoms, and this number is considered to be how much it is? So it is 6.022 into 10 power 23. This many number of carbon atoms are found in the 12 grams of this particular carbon. Hope it is clear. Now see the next, this number is fixed numerical value of Avogadro constant. Okay, we will be indicating this Avogadro number with symbol Na. Okay, so it is very important, that's why I am repeatedly saying the same term. Okay, and what is the unit for this? So it is the unit for mole is, mole itself is a unit. So in 1 mole, this many number of particles are there. Okay, so I can say Avogadro number of particles per mole. See, Avogadro number of particles per mole. Okay, so that's what. Okay, you can write this just you can write this, 1 mole of atoms is nothing but 6.022 into 10 power 23 atoms. Okay, so now if I say 2 moles, so 2 into Avogadro number, that's it. Okay, so something like a pair of shoes means 2 shoes we are saying, dozen x means 12x we are saying now. Similarly, 1 grass of pencil means 144 pencils we are saying. Similarly, if I say 1 mole of hydrogen or 1 mole of anything, like 1 mole of hydrogen atoms means Avogadro number of hydrogen atoms, that is 6.022 into 10 power 23 hydrogen atoms are there. Like this you need to identify or understand. Hope it is clear. Now let us also say, see, every substance has some mass, right? Right. Okay. So now like for example eggs or whatever we are saying in our daily life, everything is having some like some weight, mass is there now. So now here we discussed about one like mole now. So whenever we are saying 1 mole of substance, the weight of 1 mole of substance is considered to be its molar mass. So what is mean by molar mass? It is a weight of 1 mole of that particular substance. Okay, so here the mass of 1 mole of entities is expressed in grams. So that is what? It's molar mass. It means that mass is corresponds to how many particles? Avogadro number of particles. For example, here I am writing 12 grams of C12 carbon. So this is the mass of Avogadro number of particles. Okay, so if I say 1 mole of carbon, if I say, so it is nothing but we can say that it has 12 grams of carbon. Okay, and I can also say it contains this many number of carbon particles or carbon atoms are there. Okay, so this is how you can understand. Okay, now what I am giving you is, so if I instead of saying 12 grams, if I only say 6 grams of carbon, So what do you mean? What do you mean by this? See, 12 grams means 1 mole. 6 grams means half of this now. So you can say it as half mole of carbon. Hope it is clear. Now here one again, see 12 grams contains this many number of particles. So here 12 becoming 6. Okay, so this is also what happens. See, this become half now divided by 2. Therefore, we'll get this. Here also you do division by 2. Therefore, you will get a number around what? 3.011 into 10 power 23 carbon particles are there, carbon atoms are there. So like this you need to understand. So Sahu, hello sir, hi sir, yes, Susmita, Sahu, hello dear. So I hope you are following the class. So if you have any queries, write in the comment box. I am here to help you. Okay, so feel free to ask. Yes, hope it is clear what I am explaining. Right? So now if I say 6 grams, that is done. So here if I give you 3 grams of carbon, what do you mean by this 3 grams of carbon? So you can say how many moles it is? See, 12 grams means 1 mole we have discussed, right? So now 3 grams means how can we say? So see, 12 grams means 1 mole, 6 grams means half mole. Okay, and 3 grams means what? See, from here to here how much it is divided? It is again divided by 2. It means 1 by 2 divided by 2. It means 1 by 2 divided by 2 means it becomes what? 1 by 4. So it is 1 by 4 mole. Okay, so I hope it is clear. Now here see 6 grams means this many number of particles. Okay, so this number I can indicate with Na, Avogadro number. Okay, so this is nothing but half of this Avogadro number, right? Half of this Avogadro number. Now again this number has to be divided by 2, therefore it is becoming 3. Here also if we divided by 3, so I can write half, this is half of Na we have written now. Again by 2 means 1 by 4 of Na. Okay, so 1 mole means directly you are writing Na, half mole means you are writing half into Na. So here 1 by 4 mole means you are writing 1 by 4 Na. Hope it is clear. Number of particles are how many means just multiply number of moles into Avogadro number. That will give you the answer. Hope it is clear. Now, so if it is clear, then it is easy to calculate or it is easy to do the numericals also. So let us understand this. See, whenever a weight is given, weight of a substance is given, just divide it by its molar mass, divided by its molar mass. Okay, divided by molar mass. So what it will be giving us? It gives us number of moles. What it will give? Number of moles. So weight you should express in grams. Okay, so molar mass is what I told you, it is a mass of 1 mole of substance. So you can take here it as gram per mole. Okay, so here gram get cancelled, so you will be remaining with unit mole. So mole is a MOL here we are writing now. So this is a unit of number of moles. Okay, so how we got this formula? Just look here. So when we have 12 grams, we got 1 mole. Okay, when we have 6 grams, we are saying half mole. It is nothing but 6 by 12 gives half only, no? Like that. Here I have given 3 grams. 3 divided by 12. So what? How much it is? 3 by 12. How much it is? 1 by 4 only, no? Yes, 1 by 4 mole we got. Hope it is clear how we are understanding the formula also. Right? Clear now? Now it is about weight by molar mass gives number of moles. Okay, let us do some questions here. So number of oxygen atoms in 4.4 grams of CO2 is. So how can we answer this kind of question? See, first of all, whatever the quantity they have given, so whatever the quantity they have given, convert it into number of moles. How can we convert into number of moles? Take number of moles equals to number of moles of CO2. First of all, calculate number of moles of CO2 we have. Yes, how many number of moles? Given weight now, take given weight as in the numerator, that is 4.4 grams. Okay, now in the down what we need to take? We know given weight divided by molar mass gives number of moles. Okay, what is the molar mass of carbon dioxide? CO2. So for carbon it is 12 and for oxygen 2 into 2 into 16. Why I am taking like this? See, what is the atomic number of carbon? We know atomic number of carbon is 6. So it means it has 6 protons and 6 neutrons. So 6 plus 6 it will become 12, right? And 2 oxygen atoms. So 2 I have written here. And what is the like atomic number of oxygen? 8. So 8 protons, 8 neutrons. So total 16. So 2 into 16. Like that I have taken, it will become 44 gram per mole. This is the molar mass of this CO2, you can say. Okay. So here you can say 44 gram per mole. Okay, this gram cancel. See, it is 4.4 by 44. So this is nothing but 10 times. It will give 4.4 into 10. It will become 44 now. So it will be 1 by 10 mole. So I can write 1 by 10 instead of writing 1 by 10. I also can write it as 0.1 mole. This many moles of carbon dioxide is present. Okay, hope it is clear how we got number of moles. Now they are not asking about number of moles. They are asking about number of oxygen atoms. So how can we say, if I say 1 mole of CO2, 1 mole of CO2, it has Avogadro number of, Na means Avogadro number of CO2 particles are there, right? How many Avogadro number of CO2 particles are there? Now see, in 1 CO2 unit, take here CO2 unit, in 1 CO2 unit, how many oxygens are there? 1 unit contains 2 oxygen atoms, no? So 2 oxygen atoms, like this you need to say. Okay, if I say 1 mole of CO2, it means how many oxygen atoms are there in this? So this one multiplied, Na multiplied, Avogadro number multiplied with, in 1 oxygen atom, 1 carbon dioxide we have 2 now, so multiply with 2, that's it. That will be your answer for 1 mole. Here it is given as 0.1 now. So if it is 1 mole, that's that much. If it is 0.1 mole, multiply Avogadro 0.1 mole, number of moles into its Avogadro number into its atomicity. Atomicity means what? Number of atoms of that particular element. How many atoms are of the oxygen atoms are there here? 2, right? So multiply that 2. So it will be how much? 0.2 Na will be your answer. Hope it is clear. So what is the generalized formula here we can make? So number of atoms, if someone asks you, so how can we do that? So number of atoms is equals to, take number of moles, in small n represents number of moles into its Avogadro number. Avogadro number we know now, that is a constant value. It will be always same. It is 6.022 into 10 power 23. Fix that. Into what? Into number of moles into Avogadro number into its atomicity. Atomicity means what? Number of atoms of particular species. It means what is the atomicity of carbon in this CO2? It means it is 1. Only 1 carbon atom is there na, in this one formula unit. So it is 1. What is the atomicity of oxygen in CO2? It is 2. Why it is 2? 2 atoms are there na in one formula unit. So it is 2. Now tell me, what is the formula, what is the atomicity of hydrogen in glucose or in sucrose? Like that they will ask you. So in glucose, if we say, what is the formula of glucose? C6H12O6 they will be giving you, right? So in this, how many hydrogens are there in one formula unit? 12. So what is the atomicity of hydrogen in glucose? It is 12. Okay, and what is the atomicity of carbon in glucose? In glucose unit you can see 6 is there now, that will be the atomicity of carbon. What is the atomicity of oxygen here? 6. Like that you need to understand. Hope it is clear. Now let us move little more. Now tell me, what is the answer here? What is the answer for this particular question? Number of moles are 0.1. Avogadro number is 6.022 into 10 power 23. And what is the atomicity we got? Oxygen atom is 2. So multiply with 2. So how much? See, 0.1. It means 10 power minus 1. This is 10 power 23 is there now. So I can write it as 10 power 22. Okay, and 6 to the 12. So 12 into 10 power 22. Do we have any options like that? 12 into 10 power 22? No, 12 into 10 power 23 is there. Instead, I can also make this option as per the options, I can make it as 1.2 into 10 power 23. That's it. So we have option number 1 like this. So I can say 1.2 into 10 power 23 is our answer. Hope it is clear how we are solving this kind of questions. Yes. So I request or I suggest you to just click on the like button if you really like the session. Okay. So we will continue further sessions with your interest. I mean, if you show more interest and if you share with your friends, really if the number of counts, viewer count increases, we will definitely continue the session for the next 100 days without any disturbance. Okay. So I request you to share with your friends, those who are preparing for JEE, NEET or EAP set. This will be definitely helpful for them, right? Hope it will be definitely helpful, right? So you can share and both of you can watch and you can write in the comment box whatever the queries you have, we will discuss. Okay, now tell me what is the answer for this? Which of the following contains atoms equal to those in 12 grams of magnesium? So will you try this? Yes. So look here, which of the following contains atoms equal to those in 12 grams of magnesium? Okay. So you take number of moles. First of all, we need to find number of moles. Atoms they are asking means multiply the number of moles into Avogadro number, that's it. Okay. So number of moles, how many? 12 grams is given, 12 grams of magnesium is given, divided by Avogadro molar mass 24 gram per mole. So how much we will get? So this will be 2 times, so half mole we got, 0.5 mole we got. So this is the number of moles of magnesium given. Okay. So 0.5 moles you can directly write 0.5 into Na. This many number of magnesium atoms are there. Number of moles or number of Mg atom, magnesium atoms are this many. Now if you do it for this, how much you will get? So given weight is 12, its molar mass also 12, so we will get 1 mole. It means 1 into Na number of particles. So it is not correct. So take this. So given weight is 7 grams, divide it with this one. Divide it with this one, I mean N2. N2 means it is a nitrogen molecule now, so it will be 28. Okay. So take molar mass as 28, and what is this? Is the number of moles we got now up to here. This is the number of moles we got. Number of moles into its Avogadro number into its atomicity. Atomicity is 2. This will give number of atoms. Number of atoms. Should not get confused between number of molecules, number of atoms, anything like that if they ask. See, they are asking about number of atoms. Here it is given molecule. One molecule contains how many nitrogen atoms? So 2 now, multiply with 2. That's it. See, this is 4 times. Okay. So 4 2 times, this is 1 time. So 1 by 2 Na. So here number of atoms of nitrogen, in B is same as the number of magnesium atoms. So what is the suitable answer here? It is option B and not A. Okay, you can verify for this, so you will get a wrong answer for this. Only option B is correct for this particular question. Hope it is clear, right? Now let us move further. Which of the following represents 180 grams of water correctly? Okay, so 180 grams means, how can we understand this? Just find number of moles. How many moles it represents? 180 grams. Given weight is 180 grams. Divide by what is the molar mass of water? So it is 18 gram per mole. Okay. So why we are doing like this? So it will give us number of moles. 10 moles is given here. Okay. So 10 moles of water. Yes, here we have 10 moles of water. That is directly correct. Okay. We can also check for the other options also. Is this correct? 5 moles of water? No, it is not 5 moles of water. Which are the following represents 180 grams of water? Yes, 180 grams we can express as 10 moles of water, right? And also we can also express these number of moles is this many na, multiply number of moles with Avogadro number. So how much we will get? 10 into Avogadro number is 6.023 or 22 into 10 power 23 we will get. So this is 6.023 into 10 power 24 also correct. Okay. So both option 2 and option 4 is correct for this particular question. Hope it is clear how we are solving this kind of questions, right? Right. So if it is clear, just click on the like button. Okay. Yes. The next, so methods of calculation. So first method we have seen, if given weight is given, just take given weight by molar mass. So this is the one way of calculating number of moles. And the next way, see, we know 1 mole means 1 mole of a substance means we are saying Avogadro number of particles, Avogadro number of atoms, right? So now if I ask you, if I give you some Avogadro number instead of giving you Avogadro number, so I am saying some Avogadro, instead of giving Avogadro number, here I am giving you x number of atoms, x number of particles I am giving you, x number of particles I am giving you, particles I am giving you. I am asking you number of moles, number of moles. So how can we do this? Number of moles I want. So just take the unitary method, see, multiply with these two and take multiply with these two. So what we will get? So number of moles equals to number of moles into Avogadro number Na gives 1 mole into x number of particles, x number of particles into 1 mole. Oh, okay, so we got our answer. See, I want number of moles only, na? So number of moles, let us indicate the symbol with n. So n equals to, small n equals to number of particles x by its Avogadro number, that's it, x by Na. So if in the given question number of particles is given, so if the given question contains only number of particles, so divide it with the Avogadro number so that you will get number of moles of that particular substance. For example, so what is the second formula I made? This is the first formula. So second formula is number of moles equals to number of particles divided by Avogadro number. For example, here let us say instead of saying 12 grams, 6 grams like that, I am telling you to take 6 grams of 12C carbon. 6 grams of 12C carbon contains, like this, if they ask, you will say half mole, right? So instead of asking like this, I will be giving you 3.011 into 10 power 23 carbon atoms are there. Carbon atoms are given. Okay, now express in terms of number of moles. How many moles it means? So number of moles formula what we have? So number of moles equals to number of particles given is 3.011 into 10 power 23 by Avogadro number. What is Avogadro number? We know 6.022 into 10 power 23. That's it. See, given number of particles by Avogadro number. Given number of particles by Avogadro number. So what we got here? So this and this get cancelled. So this multiplied with 2 will gives this 6.022. So it will be written as half mole. Hope it is clear how we are calculating number of moles using number of particles. Okay, so this is the second formula. Then next, here look here, so this is NEET 2024 question. Highest number of helium atoms is in which of these highest number of helium atoms are present? Look here, so it is given as 2.24. okay, so here STP means what? STP means standard temperature and pressure. Okay, it means generally temperature is taken as 273 Kelvin, okay, 273 Kelvin or 0 degrees I can say, and pressure as 1 atm. Okay, so pressure as 1 atm. So at this condition, the volume occupied by any gas particles or any gas molecule will be 22.4 liter. Okay, 1 mole of any gas substance, any gaseous substance occupies how much? This much volume of the given container. Okay, so now I am saying you, if the temperature is kept same, see, temperature is remains same, but I am taking 1 bar pressure. So here when I am taking 1 bar pressure, see, atmosphere pressure are having relatively small difference in them now. So in this case the volume, see, since pressure is changed, volume also changes. So here 1 mole of the substance occupies 22.7 liters. So just by changing little in the pressure, the occupied volume also changed. It means the pressure and temperature has to be mentioned, then only we can express that volume occupied by 1 mole of substance using this Avogadro's hypothesis. So what is this called? Avogadro's hypothesis we can say. Okay, so now see, here it is given as 2.27. see, if I give 1 mole of helium, how much it will be having volume? 22.7. so they given it as 2.27. it means they divided this number by 10. so divided by 10 means this side also divide by 10. so 2.27 means how many moles it is? it is 0.1 mole. okay, 0.1 mole of helium. so this is how you can understand. okay, so now it is 0.1 mole. Then next, here it is 4 mole. so which is bigger number? 4 mole is bigger number than this 0.1 na? so it is having maximum number of particles in the first case. okay, so option 1 cannot be the answer. Next, here it is just given as 4 units. okay, here it is given as 4 grams. for 4 grams, given 4 grams, given weight by its molar mass also 4. so divide, you will get 1 mole. so in this, so what you can understand, so it will be having 1 mole. so it is very less. 4 units means very less number of particles, 4 particles only. and here we have what? 4 moles. so which is having more number of moles? the more the number of moles, multiply number of moles into Avogadro number, that will be giving us maximum number of particles. okay, more the number of moles, more is the number of particular atom. so I can go with option number 2. hope it is also clear. Next, let us move forward. Now this is important. Look here, the total number of protons in 10 grams of calcium carbonate. so how can we say this total number of protons? see, so given weight is 10. so first write the formula of calcium carbonate, CaCO3. okay, so this is a formula. so who is this? Jatin, hey Jatin, fine. hello man. yeah, so CaCO3 we have now. so CaCO3 means calcium. What is the atomic number? It is 20. so now they are asking about given 10 grams and they are asking total number of particles. so find its molar mass. so find its molar mass. for calcium it is 40 and for carbon it is 12. for oxygen 16 means 3 multiplied the 16 you will get 48. so total sum will be 100. okay, this is the molar mass of calcium carbonate. so why we are finding molar mass here? see, they are asking number of protons. so whatever the question they are asking, so first of all you need to know the clear cut idea about number of moles in a given substance. so number of moles, how can we calculate? given weight by its molar mass. molar mass is 100 gram per mole, right? so this mole cancel, this will be getting 10. so number of moles is 0.1 mole. so this many number of calcium carbonate units are there. okay, so now 0.1 mole is perfect. They are not asking about number of calcium carbonate units. They are asking number of protons in this 0.1 mole of calcium carbonate. See, what is the atomic number of calcium? 20. It means 20 protons are there. So calcium contains 20 protons. Okay, and carbon contains 12 protons, and oxygen contains 24. Okay, so totally how much it will be? See, calcium atomic number is 20, so 20 protons. Carbon atomic number is 6, so it is 6 protons, and oxygen atomic number is 8, so 8 3 is a 24, so 24. You can take like this, so 30, 50. So this will be the answer. So you can say number of protons, it means number of moles is this many. So number of protons they are asking now. So what I told you, number of protons, formula is what now? Number of protons equals to number of moles into Avogadro number into in one proton, in 1 unit of the CaCO3, how many particles are there, how many proton units are there? 50. Write that 50, that's it. So what is the number of moles here? We got 0.1 into Avogadro number, so 6.023 into 10 power 23 they mentioned it, so into 50. You can take it like this, so 0.1 into 0, remove that, so 5 6 are 30, so it will be around 30 into 10 power 23. Do we have any options like this? No. So you can write this as 3.0 into 10 power 24. Yes. Now we have an option number 3 which is appropriate answer for this particular question. Hope it is clear how easily we are solving. Jatin, hi sir. Hi sir, मैं 10th में हूँ, लगता है गलत लाइव यहाँ पर. Okay. So Jatin, if you are in 10th class, see we are already doing our 10th class session separately. I mean like whatever the chapter you have, acids, bases and chemical reactions and equations, I have covered them. So you can go through the playlist and you can watch it. Okay, and you can join in those sessions. It will be helpful for you. Okay, if it is only for boards, you can watch that, and if you are preparing for JEE and NEET, you can join these sessions also. Hope it is clear, Jatin. Okay, then next, yeah, so the remaining thing, whatever the remaining things are there, I mean we have many things to be calculated. Yes, so this take it as homework and write in the comment box. I will be waiting for the answer in the comment box. Okay, no issues, even it is wrong also, I will be looking into it. Okay, so just give a try to answer this question similar to whatever we did in the previous case, and this one also, this one we did now. Yeah. So percentage composition I will explain you. Try to answer this question also. Both, whatever I have shown you as homework 1 and this is homework 2. So these are the two homework questions I am giving you. Write in the comment box answers of this particular questions. Okay, no issues, even it is wrong, no one is going to say anything. I will be helping you the proper way if you are doing any wrong in the question. Okay, hope session is really helpful for you, and the next we have mathematics and physics sessions. You can join through that. Okay, thank you for watching.